And another draft physics video presentation. Comments, some videos, whatnot, mostly about light and such. Interferometers maybe we'll get to, and such. Maybe. See how it goes. So Zohar has made a 2-minute and 23-second video. I don't know. Yeah. Attempting to describe gravity. It's really just too brief to be useful, I think. Not enough context, and but it did give me a thought on a better way to explain how a mechanism of thermal equilibrium, which the Earth is in, as much stuff goes out as goes in. It's not getting any bigger. It's not collecting anything permanently. It's just in an active state, and how that active state inherently creates gravity. So I have pointed out that we are all just bouncing on the surface of the Earth and attempted. I think it's something you could understand. You can feel it. You can feel the pressure, and the pressure isn't pushing you in one direction, right? You don't go in one direction, right? You feel the Earth pushing, yet you don't go anywhere. So obviously you're going back the other way. So the idea is when something's on the surface of the Earth, it's bouncing on the surface of the Earth. And so I've made this point that this explains why our velocity, on the surface of the Earth is higher, than the velocity of a satellite hurling through space. Because even though this thing is going faster than us in one direction, it's wobbling a much slower, in the sense that there's less pressure pushing it down, less pressure pushing it up, so it therefore doesn't bounce as much, not the same amplitude. You can either increase the frequency of these lines or increase the amplitude of them to describe the effect. So when you're in stronger gravity, you're actually traveling like a basketball, somebody dribbling a basketball. The basketball is going much faster than the basketball player, because the ball has to travel a lot more distance. So if you can accept that argument being reasonable, that pieces of your matter at any one moment inside your body, there's pieces going down and there's pieces going up. They're not just going based on the velocity of the Earth spinning. This isn't your only velocity, right? You got the Earth moving through space, and then you got you spinning on the Earth, and you got all this, complex effects. So at any one moment, pieces of you, the atoms, the electrons, and the protons, are changing their position in space based on your net direction, what the total all adds up to. And your electrons and protons are individually doing things. They're going in directions. Some are going this way, some are going this way at any one moment. But there's a net direction where they're going. Over time, more of them go one direction than another direction, and that's how we move through absolute space. The place that we all exist in is absolute space. So this comes up because there's a snarky comment about relativity, so this will be applicable to that comment also. So anyway, so the simple argument to be made is that if you have an observer, you have two objects in space, and you could sort of understand that if I could move this object this way, and then move it back, and then move it this way, and then move it back, that what in effect is happening? Well, you could argue that it takes force to move it that way, so you absorb a force that was going this way. So let's say the force is going the speed of light, but the object is only going 1/2 the speed of light. So it covers the distance slower. So essentially, the force that was going the speed of light is reduced to going 1/2 the speed of light when it bangs into a piece of matter. So when it's pushing a piece of matter, it's only going 1/2 the speed of light. So you can understand it's losing energy, all right, by moving matter, right? So in the pure universe, the force going this way is equal to the force going this way. There's a balance in the universe, and so you could argue that that's the state when there's nothing in the environment. But if something's in the environment, So you know that a force going this way to go for this thing to push out a little bit, for one piece of matter to move a little bit out, it had to absorb energy. So we absorbed something going, let's do the total over here. So we absorbed energy going this way, we cut it in half. We cut its energy in half by slowing it down to move a piece of matter from this position to this position. And then when we stop it, okay, we're absorbing energy this way. So, we absorb a piece going this way. And then to get it moving again this way, all right, we have to absorb more energy that way. And then when we stop it again, stopping it will absorb energy going this way. And then to get it moving again requires you to absorb energy this way. Now, the trick is that all this is energy absorbed. So we absorbed, you could just say, a half quanta of energy on each one of these things. But what's the net effect of this? Is that you absorbed energy going both ways. You still have balance, you have equilibrium, but what does this thing see? Okay, well, the energy absorbed this way, it can't possibly see that. It doesn't know that happened in the universe. Oh, you mean a piece of energy that left me got slowed down? I have absolutely no way of caring or knowing, so some energy didn't get to the wall over there because there's a lamp in the way. I don't know. I don't care. But I clearly care about the energy that didn't get to me. Okay, so the energy it took to move the thing this way, all of that I'm going to notice because it doesn't get to me on time. Okay, I'm not getting as much energy because some of it was used up to move this object. So you can understand that this could just be an atom on the surface of the Earth right below you. That atom right now is moving in pressure because you're putting pressure on it, right? Gravity's putting pressure on it. And then the Earth is pushing back. The other stuff is pushing the other direction. So I'm just saying that it's kind of easy to see that it just happens to be a quirk of nature, that if you do occupy energy moving, right? If you're moving matter, you're absorbing the energy of the quanta. It has less energy, all right? Because it's half the speed it's moving now while it's moving the matter. So just think of it as sticking to it. A little piece sticks to it and another piece has to hit it and that sticks to it and this piece goes off. So just think of it as while the piece is stuck to it, it's only going half the speed it usually goes. So it's lost time in reality. It's lost part of its energy. So anyway, so it just has to do with the point of view, okay, of this observer in terms of the fact that it can't see all the absorptions in this direction, but it does see all of the absorptions in this direction. So even though there's equilibrium, from the observer's point of view, there's a deficit. And the deficit is just made out of the fact that movement costs energy. And energy didn't get here because it was used up moving pieces of the Earth. So every object that creates gravity can only create it by having stuff inside of it going the way towards you. And yes, the stuff going the opposite way gives it equilibrium, but you can't see the equilibrium. You only see the deficit. You don't see the opposite reaction inside the object has no effect on you. And that's the key to understanding why things that are at equilibrium still have gravity. I mean, it's physics. I can't make it much simpler, and still be physics. But you should be able to get this, okay, that energy is absorbed in movement, and every object that ends up having gravity has to be absorbing energy. It's wasting it, moving, jiggling. Jiggling uses energy. It makes the universe, less out here. Everything out here is less affected if there's some matter here jiggling. It's using up energy that would be in the field, and it's not there now because it's jiggling. It's moving. Moving matter uses environmental energy. It takes energy out of the environment, okay, to move the matter. That should be enough. All right, so to the comments. All right, Tween 12. Thank you, Gary. I'm not an expert, but I took physics and chemistry in college and believe I understand you. I know it means nothing, but I am a 1 in 100 in math in the nation in math expert. Yeah, well, that's might be useful sometime actually. Have to apply that somewhere. Anyway, I mean, I wish math was as important as they claim it is, because it really isn't. It's just another way of drawing a picture. It's another way of formalizing variables. Yeah, I just pointed out to you variables. A piece of matter moving, and there's consequences to the matter moving. Okay, there's velocity absorbed, which is the same thing as absorbing energy. See? And you could write an equation to show you that, but I can draw you a picture showing you that. All right. So this was just a stupid, snarky comment that is just so cliche and typical. So, I mean, this, I really will someday, if I ever get rich, build an asshole Hall of Fame, ass wipe Hall of Fame. And all of you will be in it, we'll have nice images of you and everything, and just say, look at this asshole. Look at how he got through his life with this kind of tripe. So I just did a video pointing out how there's an MIT college professor looking at the two-slit experiment with the two patterns and pretending it isn't there. I mean, he's pretending it isn't there. That's the video this guy is commenting on. They have mathematics where I have to explain to them, right, that predicting we can predict exactly where the bright and light spots are. And they're projecting it on a flat screen. They're not even smart enough to know that they're projecting it on a flat screen, which means they're totally distorting it. So their math says the thing should be 1 millimeter, right? Well, 1 millimeter over here is going to be 7 millimeters. So because they're too stupid, is that it? You're all too stupid to figure out that, oh yeah, all of these patterns will get preposterously long and distorted the further out I go. So the bigger I make the angle, the more preposterous the size gets. It has nothing. It's no relation to reality anymore, right? And I have to explain that to you? I mean, you're too stupid to know that it's really unscientific to talk about a projection without taking into account that, oh yeah, well, the projection should be understood as being equidistant. And when you do that, you realize, oh, it's a very finite pattern. It goes from this 0 degrees, you could say, to 90 degrees. And at 90 degrees, the two lines from the 2 point sources are exactly the same length. And at 0 degrees, the two lines are exactly a number of wavelengths, okay, longer or shorter. And those number of wavelengths just happen to be, something you could just mark right here on this scale. So that's in my video. He doesn't respond to that. He doesn't explain how, well, it's okay for MIT professors first not to know that projecting on a flat screen distorts your image, and your math can't hardly be perfect because it's not accounting for the fact that if you actually measured it with a ruler, your answer wouldn't be close to correct. When the math isn't accurate, it isn't close, it's completely wrong. The answer will be wrong. If I used the MIT equation to see how big the bright spot will be here, it will give me the wrong answer. Because the spot isn't really here, it's here. Okay, it's here and it's here. That's where it really is. If you want to know where it actually is and what in actual real proportions, this is what you projected on. So, your pretense that you're a know-it-all, that you know something and somebody else doesn't know anything, again, is just absolute garbage, because you can't even confirm and acknowledge Well, gee, MIT professors should know that you can't project it onto a flat screen. That's really dumb. And they also should be able to figure out, oh yeah, it is a finite pattern because there's only so many sine thetas that are a wavelength difference in this arc. This arc is a finite thing. It's not an infinite thing. I mean, you people are so despicable. All right, so anyway. Wow, you've taken your 1 in 100 skill set and gone a long way. How do you know what he's done? But anyway, are you familiar with the Michelson-Morley experiment? Amazing tripe, right? Proves absolutely nothing because they don't even know how it actually works, which is the funniest part of the whole thing. They can't draw you a picture of what the photon is doing. No picture. You know, if you actually understood math, so again, this understanding math. No, if I understand drawings, can you draw a flat screen versus a curved screen and explain why they're different? Yeah, I can. See, it's really easy to do. Now, you can project a whole bunch of complex math to explain this difference, but you don't really need that, do you? Because you can see it. Okay. Which you, of course, don't. You're just hiding behind your convoluted bullshit math. Again, Einstein's math, I'll bet you, okay, I've seen the conversation between math geeks. And the real conversation, the conversation about what Einstein's really doing, okay, in his field equations is accounting for something that just, when you think about it, is so obvious. That with all the other planets, moving around the sun, right? The sun at any one moment, all right, moves. The center of the sun's gravity actually changes from moment to moment. And so the sun is in fact processing. Okay, it doesn't have a consistent, it stays within the same area, but it's processing, okay, as it spins in space. It's processing, it's moving in an eccentric manner, all right, within a confined space. Maybe that space is only 5 miles, but it doesn't really matter. And the key is Mercury's so much closer than all the other planets that of course that precession affects Mercury, and Mercury precesses a little. Okay, of course. The sun is wobbling, Mercury wobbles. Yes, not complicated. So all that convoluted math is really just doing this. That's all. And all the other planets are not affected nearly enough because gravity by the r² rule gets weaker and weaker. So obviously any wobble in the sun ain't going to be any wobble in the Earth because it's too far away. So clearly it explains why Mercury's an aberrant. Newton's math does everybody else okay. It doesn't quite work for Mercury. Well, the reason is because Newton says the sun is here and it never moves. So that's the problem with Newton's math, is he's not moving the sun. And if you move the sun, then you can move Mercury. All right. If you actually understood math, which you of course don't, so he proved that with nothing, then you realize why the null result in that experiment leads to special relativity. How does it do that? So again, the only thing relativity is arguing is that it's replacing one ether with another ether. Okay, it's just replacing ether with a thing called bent space. Okay, some new source of magical energy where something just says, I have to fall into the well, the invisible well of bullshit. And so it's just nonsense, right? So again, we're just talking about the fact that in the end, you can understand that gravity, okay, so this is, the general relativity horseshit versus the velocity argument. So the one argument is velocity, okay, affects the matter. Matter is affected by velocity. The other argument is that gravity, acceleration affects matter. Well, they're both the same thing. Acceleration is velocity. Okay, so there's no separation. And again, so if you understand that you're actually increasing your velocity when you're accelerating down on the Earth, because your actual velocity, okay, has to account for the fact that you're traveling a line, okay, not straight. All right. So therefore, what's faster? I mean, what's moving faster? This or this if it's covering the same distance, the same amount of time. So if it doesn't change its time and it's doing this, then it has to change its velocity. That's the only way it could have a consistent velocity this way, is for it to increase its velocity when it's doing this, quite obviously. All right, anyway, the bigger point to get to is the whole Michelson-Morley thing depended on the fact that there was a claim that there was an ether, okay, some sort of stuff that had to be moved for light to move through it. So if you understand that, no, light just moves from point A to point B at a constant speed, and it doesn't care about any ethers, it doesn't care about any goop, it doesn't care about any of this crap, then you'd understand, oh, there can't possibly be any difference. And understand that, making some kind of experiment where you go this way and then you go this way in space, you travel this way versus this way, it doesn't matter if the whole experiment's traveling that way. It's not going to change anything from a photon's point of view, okay? Except you won't be able to even do the experiment, as Einstein pointed out. So the point is shortening this distance by going faster, okay? So you're shortening the distance. Obviously, you emit something, and you're moving into this other target, okay? So as the light's going this way, you're also moving into the target. Obviously, it's going to change when you hit this wall. But if the one going this way, the problem is you can't hit this wall because the wall moved from here to here. So you don't even hit the wall. If I increase the speed enough, you don't even hit it. So if there's a mirror there, you're not even going to hit it in the same place. And if it's an angled mirror, of course, you're going to hit it here versus here. Well, those are longer distances. So none of it makes any sense to try to sit there and make a device that can see your movement, except to make the simplest one, a light clock. Just move the light back and forth. And if you have any movement, you should be able to see the target, your movement, make the light not hit what it's supposed to. Versus, like I said, if you're going one direction, if you're going with your momentum, right? If you have any real momentum and you go with it, then you're going to be moving your target further away. And if you go against that, you're going to be moving it in this direction. So you're not going to change when it hits the mirror, you're going to change where it hits the mirror. So if you make the mirror big enough, this time shouldn't change versus this time, depending on which way the velocity is. But again, we don't have instruments that can do any of this at our slow speeds. Alright, so let me just finish this. Leads to special relativity, and once you understand relativity, GR is conceptually not much more difficult, although the math functions are. So you're conceding the point, but again, you're not relevant to the video at all. The math demonstrated in the video is the math that's wrong, okay? The wave centers are in the wrong place in the math that works. Your images don't match the contentions. That's what's in the video. Where did you respond to that with this lame horse shit? You just evaded the subject of the video and changed the subject, assuming you can get away with that. You horse shit coward. Okay, let me guess. You took funny book physics, so just more ad hominem crapola. You can't make a real argument, huh? So he says even funny book physics proves Gary wrong, by the way. Well, he's not wrong about the projection screen argument, is he? No, you can't make any argument he is. But I can prove Professor Lewin's wrong. I can show you again his clip of him looking at a two-slit experiment and going, lights on, lights off, lights on, lights off, and so on. When that's not the pattern, clearly. He can't even describe a frickin' on-off pattern, a piece of Morse code correctly. And you're fucking insulting me? Yeah, that's how lame you are. Prove Gary wrong, by the way. Gentleman C, right? Well, whatever that, I don't know what the fuck that means, but fuck you. Fuck you. Fuck you. I won't block you yet, because I'll see. Do you have any balls at all, you coward? You fucking coward? Yeah, let's see what you know. Because I'd say you know shit. Okay, so let's see you show up and actually make a real comment relevant to the assertions made. Does it make any sense to project the double slit experiment onto a flat screen and then talk about how you have perfect math telling you exactly where the bright and dark spots will be? Does that make any physical fucking sense? Fuckhead. Okay. Alright, perv action. Okay. I don't know why this thing just always changes where the fucking video was. Not one single commenter, so that's a quote from me. Well, somebody's abyss is staring back at them. Well, I really don't like that kind of a talk. It's a little wooey, isn't it? But no, look, obviously the statement I was making is there isn't any concession from any of these people who complain, okay, defend the authority, conceding that they wish they had better evidence. The evidence should be kind of like evolution, where you stack up tons of it, geology, fossils, DNA, chemistry, all that shit. They don't have any of that. They have these tiny little shreds, and I'm demonstrating that it's the simplest goddamn experiment you could possibly contrive, just about. I mean, you can't get much simpler. Fucking hole in a surface. And they can't describe this experiment accurately. They can't deal with what this experiment does without perverting it, without showing it to you in special little ways that are conducive to their theory, and ignoring all the things it does that they don't like, all the things they can't explain, like the big center and the single slit, and then the fact that the double slit creates two patterns. They ignore things that are right there in your face like that. They have no explanation, nothing. No clue. Their theory doesn't work. It doesn't create the answer, the right answer. And here it is, the simplest goddamn experiment. Just imagine what kind of games they're playing with the complex experiments. Come on. So anyway, you gaslighting. Fuck you. I mean, fuck you. Are you really worth the trouble? Are you? Have you made some brilliant contribution here that I should be so fucking grateful for you just implying that somehow, oh gee, I've so cheated here because I'm basically pointing out that not one, okay, of these fucking assholes can even admit the evidence is weak. And you're saying that's gaslighting. Fuck you. Okay, I've been open about my preferable stance to you. I don't care. Do I care? No, I don't care. You make arguments or fuck off. Your theory in comparison to others. I don't know what others are. Several of your videos attest to that. So what? Again, look, I'm saying some of your comments were good subjects to bring up because something I was saying you didn't understand. That's great, so I say it better. Fine. Excellent. Thank you very much for that. But this crap? No thank you. Alright, that being said, good luck with the debate, by which I mean the cooperation of the other participants and the technology involved. I don't even know what the fuck that means. Yes, good luck with the technology, and good luck, okay, trying to get them to stay on the subject. Okay, that's be the tricky part. Okay. So, whatever. I'm sorry you feel slighted because I didn't say, oh yeah, well there's perv action who sort of gives me this, lukewarmish kind of confirmation that I might be onto something. And maybe once he said it, I don't know. I don't remember you actually saying it. Yes, it is amazing how all this weakly evidenced physics exists. That they can make so many claims about 400 particles that exist, and antiparticles, and quarks, and this and that. All these claims, and their evidence is so fucking vaporous. It's a tiny, tiny, tiny bit of evidence that they're basing their conclusions on. Very complex experiments. And, often experiments that were never performed, which is really sad. So anyway, I'm going to delete your comment because I consider it fuck youable. Anyway, gaslighting. Anyway, Piro, you don't seem to. So again, no concession. Not on the subject again. Which is the obvious what Professor Lewin was talking about. And no, just forget about that. I don't care. I'm not going to pay attention to the perfectly sound argument you just made, and instead I'm going to bring up another subject. And that's always the evasions. You don't seem to be taking into account the case where they send a single photon. Well, yeah, I have. I've done whole videos on it. It's kind of it's another one of these subjects where I have to explain to a physicist how physics works. All right, you can't do the experiment until first. All right, so let's understand the context of this experiment. It was supposed to have been done by some French guy, whatever, 100, 200 years ago, right? Sometime after Young. So, yeah, maybe 150 years ago. So some French guy did a slit experiment and sent the light to a photographic paper, right? So that's good. I mean, that's going to get you a reliable outcome anyway. But we have no evidence of this. This doesn't exist, his photograph, as far as I know. It's nowhere. It's not in a museum somewhere. It's not anywhere. So the idea is he set up a light source and then put a screen in front of it of a certain thickness. And so he waited until he found a screen that produced 500 photons a day. A tiny number. So he let it run, the story is, for months. Okay, he went off and went on a sailing cruise while the experiment was running. So let's understand, he was guaranteeing, there are not too many photons going through, right? But we don't have any of the evidence, right? We don't have a picture of what he collected. So we have no idea whether this experiment actually ever took place, whether it happened, what it is, nothing. There's nothing. There's no evidence of it. I can't find any evidence of the actual experiment. So we're stuck. Okay, fine. He did it. He got a pattern. Did he get the Young pattern? Did all he get was bars? Is that all he got? So he got the Young pattern? Or did he get the actual two-slit pattern? We don't know. Nothing. We have nothing. Okay, so that's where it starts. Now, I've pointed to the Veritasium video, right? Now, see, this is the trick. Veritasium, all these people are kind of dishonest, right? Because when they set up this experiment, they figure out, hey, this isn't working. Hey, this isn't working. Hey, this isn't working. And they have to keep playing with it to make it work, to make it do what they want to do, right? So the giveaway on the Veritasium video is he's using a photo multiplier, okay? So this is, again, a device Feynman talks about, lots of people talk about. Basically, photon goes in, causes electron cascade, which increases like 1,000,000 times the power, so to speak, of the photon. It makes one photon hit a big giant snowball, and the big giant snowball creates an avalanche, and you get a big signal that we can detect. So we can detect a single photon by setting up a snowball right on top of the edge of the mountain so it can be blown over by a little bit of wind. Kind of an idea. Well, the trick is these things can be turned up to be very, very sensitive or very insensitive. So, like in the 1950s, when they're just detecting muons, an experiment actually videoed, okay, they have to put they wait for the muon to go through a scintillator. And what the scintillator does is crash the muon, and it makes a photon. And they detect the photon. Now, when they're detecting their photon, they can't have any noise photons. If they have noise photons, they're fucked. They can't do the experiment. So they have to detect. They have to be sure this thing doesn't go off anytime it wants to. So it can't just keep going beep, beep, photon, 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 photon. Right? So you can turn it down so you're detecting real photons. Now, the key to the Veritasium video, you can see right in the video, he's saying, look, there's 5 to, let's say there's 3 to 7 error photons, okay, per second. So he has 3 to 7 error photons per second going into the photo multiplier. That's with the shielding on. That's with the whole thing covered. He obviously has it turned up way too sensitive. And why does he have it way too sensitive? because he couldn't get the experiment to work otherwise. If he turns the error rate of the photo detector down, he doesn't get any photons. He doesn't get any image in the experiment. It doesn't work. The experiment only works when he has the error photons, when he has the sensitivity turned way, way, way up. So right there is a huge flaw, right? I mean, obviously photographic film would be, a better thing to be exposing, because again, those are reliable photons. If a bunch of error photons got through, we could never take a time-lapse photo. We could never take a time-lapse photo of something, because all the error photons would ruin it. So the reason he turned it way up, and that means he has to make the speed much higher, right? So he has to make the photons coming through have to go through much quicker, because he has to overcome the 5 to 7 errors that he's getting per second. He has to create a signal that's louder than the noise. And the only way to create a signal louder than the noise is to increase how fast the photons are coming. So he can't do the experiment over one day, ideally he can't do the experiment over 3 months like the French guy. Can't take 3 months to do it. Can't take 2 weeks. Can't take 1 week. Can't take 1 day. Can't take 5 hours. He has to do the whole experiment in 10 minutes. Okay? He has to make the experiment happen so fast because he has to overcome this huge error photon rate, right? And so obviously there is doubt whether he has single photons coming through at a time. That they are sometimes overlapping photons. That is, 2 photons in the same second. And that's why he's still getting a pattern. It's a shitty pattern, right? It's not a very detailed pattern. And of course he doesn't move his detector across the entire pattern, so all he sees is the middle humps. He doesn't see anything over here, so he doesn't even detect the real 2-slit pattern. So, but that's the only experiment. That's the best one I could find. Now, if you can find an experiment proving, single photons make the pattern, well, I would first argue it should be an experiment done over at least 1 day. They should do at least 12 hours. Okay, so do the experiment as slow as possible. A day. Okay, you can afford it, right? For the sake of physics, they could afford to take the proper amount of time and do the experiment really slowly enough where they're really sure 2 photons never go into the experiment at the same time. I mean, to be really sure, you have to do the experiment slowly. Okay, that's the only way you can be really sure. So let me see that experiment. Let me see the one that took 5 hours even. All right, quit showing me ones where, well, the photons are, technically, they're 1.7 seconds difference, which at the speed of light means there's only a 5% probability that any of them could be coincidental. And but don't give me that horse shit. Give me the guarantee, which is you have such a long time between the photons, like maybe 10 minutes. Maybe let's just make it 25 seconds. Some good amount of period of time, so you're guaranteed there are never 2 of them getting in there at the same time, because that's going to obviously screw the pooch. Okay, if you allow there to be a chance, then you're just allowing the experiment to be a fraud. And again, the Veritasium results indicate that the pattern is barely visible and on top of a big giant 50% noise signal. Hardly conclusive evidence of anything. All right. But again, just pointing out, you can have a photomultiplier that's shielded, and you can have it put to the proper sensitivity so it doesn't go off. There are no noise photons. It is doable. Why didn't Veritasium do it that way? Valid question. Okay, so so Piro just keeps talking. What about the detector experiments? So you just keep making claims, and my whole point is that if you analyze the evidence sucks. You're telling me it's a truth. So he's telling me that it's a truth, that they've actually done the experiment correctly. And again, correctly is you don't do the experiment while the slit is open, right? You do the experiment first with no slit, and then you send your photons and you see how many you collect in an hour. Okay, and if you only collect 25 photons in an hour, then you know you have a pretty slow rate. That's pretty good. And then you put your experiment in. If you do it this way, the reverse way, where you just sit there and send your photons through here and then only count, say that, oh, I don't have any photons coming through. There's no photons coming out when I get no signal over here. And the only time I'm going to start saying there's one photon at a time is when the signal starts showing up. Well, if a signal starts showing up, that's the whole point. The theory would be that this experiment will destroy light. Okay, that you'll actually diminish how much light can actually get here. So when the photons are broken, if they're only going in one at a time, then they basically just scatter to different locations, and you never get any photons anywhere. The only place you get one is straight through, where once in a while a photon goes through without getting disturbed, and therefore you'll get a photon here, and then you get a photon here, and a photon here, and a photon here. So that's the, if you can prove this didn't happen, okay, then you have a proof. But until you prove this doesn't happen, you don't have a proof. Alright, and the pattern will still appears. So he says U. Okay, but that single particle is only going through one slit, right? So again, he's still saying that single particle when we know photons are composite. So he pays no attention to the videos. We never update anything, never get a confirmation. What is your argument, Piro? What do you think a photon is? All right, is a photon just this much of a wave? Is that all I need and I have a photon? So is that a photon? What's a photon? Is a photon this many little humps? Or is it this many little humps? Now, how many of these is a photon, shithead? What are you calling a photon? Alright, so there is no in and out of phase, spelled with an F, unless that one particle is really a wavefront going through both slits. So he ignored everything stated in the video, ignored the fact that the pattern can be understood as a specific number of path length differences that are completely understandable as being exactly inside the length of the slits, the distance between the surfaces. Ignored all of that and just changes the subject. Oh, God, I hate this planet. What do you think about this writing? First, just say what it is. Yeah. It's about the discovery of quarks. Right. Oh, that's just such a great subject, isn't it? When you read, so go ahead. Yes, I'll leave this link up because, yeah, who wants to waste their time? Gary can barely read comments and you're posting this. So again, it's sort of irrelevant because I actually do get most of the commentary out of the comments correctly. So whether I can read well or not, really irrelevant. Did you read the document? Because the document basically illustrates just how convoluted all this horse shit is. Antiparticles are in there. All kinds of crap is in there. You believe in all that shit, do you? Yeah, well then you're an idiot. You're a dupe. A silly little dupe. Alright, just remove him. So yeah, anyway, I mean, what do you want me to say? I mean, obviously I don't think spin, I don't think electrons have anything called spin, okay? I think it's a silly, stupid, idiotic concept, all right? Atoms become magnetic by changing their shape, okay? An atom changes its shape, which means that its electrons are, say, in this condition, right? Then it's balanced, all right? So it has positive here and it has negative here. Now, obviously, if I change its shape, okay, that is, I make these electrons closer and I make these electrons further away, you can sort of get the idea that all of a sudden the charge potential of this object is very different, okay? I mean, anything looking at it from this way is going to see something more negative, right? Okay, and anything looking at it this way is going to see something, well, this looks kind of positive. Okay, by comparison. So, you can understand that, right? That this is what's creating the magnetism. The magnetic moment is just created by which way you compress the atom. I compress it this way. Okay, it's now a south magnet. I compress it this way. It's north here, it's north over here, and it's south here, and it's south here. So I've polarized the atom and made it magnetic. Durr. That explains the magnetic moment. I don't need to spin this electron around in circles. And then I don't need to make quarks out of the inside of this and have some of them spinning this way and some of them spinning this way. I don't need to do any of that crap. And I certainly couldn't draw it and make it make sense. And your whole orbiting electron theory is crap anyway, okay? Because the atoms are magnetic. They're charge potentials. And if I could make real, okay, if I could make real magnetic monopoles in the outside world here, I could make an atom. I could put the magnetic monopoles in positions, set them up just right, and they would stay in that position. Counting for the fact that gravity is going to mess you up, as gravity does with real magnets, right? We could do all kinds of interesting things with magnets if it wasn't for gravity getting in the way. People suck. Okay, this approved guy. Well, you're going to be de-approved, okay? I mean, you're violating one of my most important rules is don't type 7 comments on one video. And then you're doing it in this obnoxious fuckhead way where I just told you I am not here to debate your physics. I'm opposing the king. I have no reason to pick a fight with the officer of the mail. Okay, I'm not going to win the war by fighting with some fucking bureaucrat. All right, I agree with you, Gary. Fuck you. They interpreted wrongly the evidence. They didn't just interpret the evidence wrong. They can't even look at the pattern of it, honestly, right? It's not subject to interpretation. Professor Lewin ignoring the fact that the double slit pattern is more complicated wasn't an interpretation, okay? It was just a denial of reality. Did they tamper with the evidence via an algorithm? So again, I'm not making these accusations. You're saying it's tampering. It's okay to use algorithms. It's okay to use error correction. All these things are valid. But yes, all of them are powerful tools, and you can use them well or use them badly. Now, I think some of the gravitational lensing images indicate that some of these algorithms have gone sort of wrong on them because some of their gravitational lensing images have quirks in them that just, sort of are saying, whoops, your algorithm went wrong, right? So there'll be a little bit, they'll have some sloppy ass, almost a circle thingy. Anyway, there'll be a little bit of configuration of 4 things, little bright spots. And then the same configuration will be over here. The exact same configuration, same proportions, and going this way. And obviously, that's not consistent with gravitational lensing. Something shaped this way wouldn't be also lensed in the same rectangle in this direction. So that couldn't happen from lensing. It's clearly, this is probably something their algorithm did. If they used the method Sky Scholar, so you keep bringing up Sky Scholar, he's an idiot, okay, but fine, whatever. Okay, somebody else with a fantasy theory who does production videos. You can say this about LIGO. LIGO is doing the same thing. All of this advanced physics is using a bunch of processing of the data. That's what the accelerators do. They process the fuck out of their data. Okay, so when they tell you they found a quark or they found this or they found that, they found it because they have 15,000 million noise detectors and prediction detectors and all this stuff that's already built into, and the data doesn't look the data going in doesn't look anything like the data coming out. All right, but you can't say all of those technologies are wrong. It's just that they should be honest to say they're all dangerous. They all might do something destructive to the data. Gary is right. The same issue, what happens to cosmic background. So he's doing it again. So it's the same fucking thing. He says Sky Scholar again. You don't see how that's fucking obnoxious, fuckhead? Jesus Christ. The noise level is so high that they have to manipulate the data to make sense of it. Yeah, it is. And again, the same thing happens with particle accelerators. They have the same kind of, noise aberration. They can't tell. They're claiming they're bouncing electrons into protons, which doesn't even make any fucking sense. You know what I mean? They're the same charge. That's a problem. And we know when you bounce an electron into an electron that the two electrons never hit each other, right? You never hit an electron with an electron. Because as the two electrons get closer and closer, the force, between them can get, technically, Planck infinite kind of high. It's an incredible, you're now talking about impacts, billions and zillions of impacts per second happening between the electrons. So the pressure here gets extraordinarily high. So it's just going to end up making the two electrons repel each other, and they might repel in this direction, or all kinds of different ways they can bounce off of each other, but they never kinetically bounce off of each other. That never happens, because you can never tie this electron to a brick wall, right? I can never make this unmovable. I can never make this electron an unmovable object. There's no wall I can connect it to. There's no pressure between a bunch of other electrons that I can create that still makes this impossible to move. So you could never have a cue ball perfect interaction between two electrons, in the sense that it's I don't know how to say it, because the pressure builds up gradually, and it gradually is transmitted. It can never be instantaneous enough to be perfectly kinetic. Anyway, made up a PhD, blah, blah, blah. Again, you're just so annoying. Okay. I don't claim that light is electromagnetic radiation. Then he says this. Science claim it. I claim light use electromagnetic radiation. It uses it somehow. So the thing that's so tiny, the tiniest little Planck bit of force in the universe, the quanta that make up photons, he's claiming they use something as a medium. What does that even mean? And I've overtly claimed to you, I don't agree with that at all. There's not a shred of evidence of this fucking medium. Fuck you. Fuck you. Fuck you. Okay, but is not electromagnetic radiation. Well, I'm not gonna argue your wacky theory of whatever the fuck that is. So you say they're wrong, and then you say something just as stupid as them. And what do you want me to say? If I have a choice to argue one of them, I'm going to argue them. I'm not going to argue you. Your wacky interpretation of the same crap. Okay, if science claim light has its own energy source, yeah, it's moving the speed of light, shit for brain. Okay, we could tamper with it. I don't, you're just sitting there saying, what? Okay, and yet we cannot. Yeah, it's the smallest thing in the universe. You can't tamper with the smallest thing in the universe without tampering it with something much bigger than it. And therefore your tampering is going to leave gigantic fingerprints on it, retard. We can't pick up atoms with our fingers, can we? Yeah, well, there's no fingers you can make to touch a photon without squishing it. Even if you block light, light still happens. It does not turn off, no matter well, whatever. Fuck you. Yeah, let's assume that light move instead of repeat itself. Yeah, fuck you. The energy requirement break all of thermodynamic, even the one mentioned by Sky Scholar again. Oh, fuck you. Alright, so goodbye. We're done. I had my fill of your crap. Ugh. The problem is, Gary, there is true and real theory about reality that can ever hold water. There is no true or real theory about reality that can ever hold water. So this must be some sort of magical God theory. Oh, says you. Who are you to say so? You're the grand authority. You have found the truth that you claim we can't find. And the truth is, there's no truth. Yeah, right. Catch 22. Catch a 22. Catch a 22. Alright. Every known theory is not, except yours. Yeah. But a pure speculative idea only. If the theory can be constructed, then it can be deconstructed. So you have the theory of water where it doesn't cause wetness. I see. Even though we invented the word wetness to describe what water causes, somehow there's a flaw in the theory that water's wet. Thanks for all your video. Fuck you. I love them. And, yeah, well, you can go to hell. And big hi from the UK. I don't know. Fuck you. Fuck you and this wooey bullshit. This fucking idiotic mush. Alright, so perspective fact. I guess he argued with this idiot. Evolution is true and real, and it'll never be shown to be false. That's damn right. Yet any description of evolution can be false, real, true, or untrue. Whatever. All known theories are just someone's perception. No, they're logical constructs. One item plus one item. Okay. One. And when I put them together as a set, okay, they have two-ness. Okay? It's just a fact, okay, as a concept. And if I have 2 plus 2, I get 4-ness. Okay, these are just real things. They're real concepts, and you can't deconstruct them. They can't make them untrue. There's no way to do that. You never will do that. You'll never make two things untrue-ness. You'll never take their two-ness away. You fucking idiot. Oh, okay. Well, I'll leave this up just because he wasted an awful lot of time talking to a religious kook. Oh, another one of these idiot comments. The AKA checkerboard, you mentioned it. Let's call it the Matrix. No, fuck you. Is at the quantum level. Fuck you. You have no evidence of any fucking ether. None. Alright, there is no proof of light having an energy component. It's just too fucking stupid, except the heat it causes. Oh, man, I mean, how can you even say something that fucking stupid? Let's see what else he says. That is measurable. I mean, amazingly stupid comment. I mean, heat is actually measured in photons. Infrared. You ever heard of that? God damn. Electromagnetic radiation is not light, and vice versa. There's no vice versa. You're saying no one's ever speculated that light makes electromagnetic radiation, retard. It only goes one way. I could be wrong. Oh yeah, that's right. You could be. I think there's a guarantee that you're wrong. But the only logic that once guaranteed, what? Is that once guaranteed? I don't know what that means. Generated. Okay, is that once generated? I could be, I don't know. Light can only repeat itself. Again, you keep saying these stupid fucking things. What are you talking about? Repeat itself. I agree. It's very religious-ish. Yeah, you're just as fucking kooky. Check the claim of light. It is electromagnetic radiation. Okay, let's test this claim. Use a mirror. Oh, I mean, it's just too stupid. And point to a rainy sky. Now use a tool to measure its electrical. There's no measuring of any electrical anything, you stupid fuck. Oh, God. Where do these people come from? I already hid them. I'll just remove It's just irritating me. Alright, so we're done. Alright, so let's play some of this alcoholic guy on the interfront, Mickelson Morley, and just point out this is just, again, so superficial. And again, I have gotten no counter argument, nothing rational. That just talking about the basics of beam splitting. That beam splitting isn't this idea that, oh yeah, I sent two equal beams off on their way. It's not as simple as that. It doesn't happen in the physical reality. If you're changing the direction of the light, the two beams can't be the same anymore.
Particularly difficult practical problems in physics. He'd earned his reputation by making extremely precise measurements of the speed of light.
So when he says that, precise for his time, okay, they're not very precise by our standards.
Having completed his work on light, Michelson travelled to Europe to spend some time amongst some of the best scientists in the world. And it was there that he became fascinated with the topic that everyone was talking about, the mysterious luminiferous ether. One idea in particular captured his imagination. It had been proposed that if you could measure the speed of light accurately enough, that it might just be possible to actually deduce the properties of the ether.
And again, it doesn't make any sense to me personally, okay, that if there was an ether that you would drag through it, but whatever.
And this is how. If there was an ether, then as the Earth orbited the Sun, we should be able to detect its presence. It would be like sticking your hand out of the window of a moving car. You feel the rush of wind as the car travels through the air.
So again, you would be somehow moving matter against a force, which that part makes sense, okay, that, there is more stuff moving in the direction you're moving, you're going to hit more stuff. So even if I moved in space towards galaxies and other stars, the truth is I'd be moving into the light, and therefore, in a sense, okay, that universe gets brighter because I'm moving into it.
Michelson realized that if this picture of the...
I'm going to hit more photons per second. Just a fact. If I'm moving in the direction I'm moving, I'm going to hit more photons per second. I can't stop that from happening. I'm going to hit more grains of sand, more pieces of dust, more everything in that direction. But there's no reason to think light is at all affected by the ether. So it goes from point A to point B, and it doesn't care about which way the source is moving. Is irrelevant. It can't be slowed down or sped up.
Ether was true, then two light beams should travel at different speeds on Earth, depending on the direction they were moving through this ethereal wind.
So in a sense, they're trying to make some argument that the ether piles up in the direction you're moving, and it stretches in the direction you're moving away from. And again, the point is that not from the perspective of the light. So the light is a captured bird, okay, in a cage, and its speed is always the same. So when you have it in the cage, it has to account for whatever direction you're moving in terms of how it turns inside the cage, but it's always moving the speed of light. And when you let it go, you can't give it extra speed. You can't slow it down by moving away and then slow retard. So it's not a baseball, for fuck's sake. Light's not baseballs.
The difficulty was actually in making such a measurement. It seemed like an almost impossible task. The problem is this: the speed of light is over 186,000 miles per second. Now that's pretty nifty.
Right, so if you had to draw that line, 1 second of light, the line would be 186,000 miles. I mean, it's a huge, long frickin' preposterously long, whatever, 8-10 times around the Earth kind of thing. It's this really long, long line. The moon and back, that's how long the line is, the moon and back. So really long line, And now you're going to take two of those lines and compare the length of one to the length of the other. Realistically, no, I don't think you're going to do that.
Comparison, the Earth virtually crawls around its orbit. So the difference in speeds between those two light beams will be tiny. Something like 1 part in 100 million.
Right, so you're saying 1 part in 100 million. You just pointed it out. So you're just saying, okay, so why bother doing the experiment? It's silly, we can't do it. It's not going to work. It can't work. You've already pointed out how it can't work.
So the precision needed to get any sort of meaningful result was way beyond anything that scientists thought was possible at the time. But not so the headstrong Michelson. He began to work his way around the problem. He started to develop techniques and precision instruments that he believed would be capable of unlocking the secrets of the ether.
Right, because he believed they were doing something based on what it looked like, and now that appearance was wrong. So again, I'll just make this argument. I made it so many times, no rational counter argument. But the beam splitter he's using is fundamentally flawed, right? In the sense that first, you're going to reflect the light off the surface. Then you're going to reflect light off this surface. So you've already created distance differences. Then you're going to reflect the light off the mirror, bits that are on this surface, right? And some of the light's going to go through the mirrored bits on the surface, right? So you have these two differences. Well, we know this one, we don't know how deep into the mirror the light will go. So it could go that deep, it could go right off the surface, it could go lots of different things. So now I'm creating all kinds of different photons here. So the ones that reflected could have reflected off here, they could have reflected off here, or they could have gone inside the mirror and reflected off the mirror. So I have 3 variations. Then the one going through the opening, it's a small slit, okay? So we know what it's going to do. It's going to scatter. All right, so it's going to be diffracting. So it's going to be spreading. So the first beam that goes through the beam splitter, we know it comes out spreading. The beam that reflects, we know comes out variable in the sense that we don't know where exactly it is because some of it reflected off different depths of the mirror, but it's not spreading. So at least it's not spreading more, right? We know that our beam going in is already in trouble because it's spreading. We know it's going to spread even more this way. So now we bounce it off of a bunch of mirrors, and again, we don't know how deep it goes into the mirrors. And then we bring it back in, and so we're sending the 2 beams back again. So this one's been spreading the whole time. This one hasn't been spreading any extra. It has the natural divergence of all light, but it hasn't been spreading. And it doesn't spread till this last minute, okay? So what you're really comparing in the experiment is a beam that spread the whole time with a beam that only spread a little bit. And what you're doing is basically understanding that's a cone. They're both cones of light. And all you're going to do is move one cone inside of the other cone now in terms of distance changes. So you're going to move this cone inside of that cone. And where the 2 cones are in phase, you'll get a band of light. Where the 2 cones are out of phase, you'll get no light. And that will create your bullseye pattern. Okay. But the pattern was created right here. As soon as you went through this dusty surface, this dirty surface, okay, you already created your cone of light. So you're not measuring wavelength differences. You're measuring how much the light has spread. The difference in the spread rates between the 2 beams. That's what you're measuring.
From 1881, Michelson was taking measurements and tweaking and refining his apparatus. But it wouldn't be until 1887 at the Case School of Applied Science in Cleveland, Ohio, that Michelson would finally build a machine sensitive enough to give him some definitive answers. There, he joined forces with another scientist, Edward Morley, to conduct what was to become one of the most notorious experiments in physics.
And again, based on a technology that I say was an understanding, a mapping, a model of photons that was incomplete, completely. Nobody can show me a drawing of what the photon is doing and how it interferes. There's no rational explanation of the travel of the photon through the mechanism. I mean, by their definition, at this thing here, a wave function is supposed to be created. So there's two wave functions flying through space. Where's the wave function corrected on the other side? There's no wave functions. Not until the end.
The original apparatus was set in a solid block of sandstone and then suspended in a bath of mercury to remove any vibrations that might affect the measurements. It was incredibly high-tech and very expensive. Think of it...
All right, so it wasn't high-tech. It's high-tech for the times, but it wasn't even that high-tech for the times. I mean, it's just mirrors, for fuck's sake. And a beam of light.
As an 1880s version of the Large Hadron Collider.
I don't think so. So I think that's a silly... it's like a version of the Rolls-Royce or something. It's not that spectacularly expensive or that spectacularly complicated.
Okay, so here's how it works. Light is emitted from this source. In the middle is something called a beam splitter, which divides the light up into two paths.
Okay, and they just make it magical, right? The beam splitter costs nothing. It doesn't change anything. So again, as I pointed out, this beam is going to be longer if it reflects off the surface. The beam's going to be shorter if it reflects off the second surface of the glass. The beam's going to be even shorter if it has to go through the mirror a little bit to reflect. So there's three different variations of where this beam could be depending on which part of the mechanism it was affected by, if it was an individual photon. And as a group of photons, obviously it's going to be a net product of those three influences. So it's going to have a lot of noise in it. At any one moment it can fluctuate because there's three different variables affecting it. The beam going through, again, same problem. Did it go right next to a surface? Did it go right between two surfaces? Which one it does will really change how it's going to be affected. It's going to be scattered by the surface if it hits the surface, and it's going to be broken. Okay, and pieces of it will have to be put back together again. So again, this is about breaking photons and remaking them all over the place. This beam here was going to be made out of remade photons. Some pieces come off the surface, some pieces come off the second surface, some pieces go all the way through, and all those pieces can be realigned to create new photons.
Over here are two mirrors which reflect the light back to the middle.
So obviously he's taking all kinds of details out. So in Michelson-Morley there's 18 mirrors, okay, that are going to be bouncing the light back and forth. 18 in each direction. Yeah. Again, the problem with mirrors. How do you know how deep you went into the mirror? It has a piece of glass on the surface. It has a second layer of glass. So let's say Michelson-Morley did use reflective metals. Yeah, you don't know how deep the light went into the metal.
They recombine at the beam splitter. The light is sent down to this detector.
So the light goes both ways. So one image goes back to the source. Okay, so the source is being sent an image that's exactly the reverse of what went to the other thing. So an inverse image is sending the other way. The phase is going to be opposite. So if it's a dark center here, it's going to be a light center over there.
Now, because of the wave-like properties of light, you see a very specific pattern here. Basically, if the light has...
So again, it's because of wave. No, it's because light is scattered and broken, and you can recombine it in the phases. And when you recombine, there's certain places where the path length differences are complementary. So you can have a path length difference. You can have a path length difference from all. You can just. You really can't draw all the sources, but I'm just saying it's a variable source, and in any one of these, you can match this one to this one, and you can match this one to this one, and you can match this one to this one. But these would be off phase, so you can't match them. The pieces are still going there. There's still pieces going to the off phase places, but obviously you're creating photons that don't have the right sequence of photon. The frequency is broken because the phase is off. And the phase is off, you're sending this. Okay, this isn't seen as a photon. This is.
Traveled at the same speed along the two paths, then you see a bright spot in the middle of the pattern.
So we know that this bright spot is what is fluctuating, and they're saying the fluctuations, okay, are a wavelength of difference. And some say that a number of fluctuations equals a wavelength, so they go even further to make the instrument even more sensitive. But it's not right. See, there's no other tool to measure how wrong it is, because we don't have any way of measuring these tiny differences. We don't have any other rule there. So they're all dependent on using light experiments, and all of them have these flaws of interpretation. But really this pattern has to do with the fact that you've spread the light by scattering it to different locations. And some locations will constructively recombine and some will destructively. And they don't even have the pattern drawn right, because actually the dark spaces don't change their size, and the light bands do. Light bands are very thick towards the middle and get thinner going out, and the dark bands always stay the same size. So they're not even drawing it right. See, none of these details matter. It's just, this is physics. Fuck details. Details aren't good for the story. And that's the truth. That's the truth of the world we live in. Details are bad for the story. And that's the same truth for religion. Details are really bad. Paying attention to details and contradictions and where the story doesn't make any sense at all. Yeah, those are the parts where, oh shit, this is a really dumb theory, right? Kind of like when Jesus says Moses was full of shit. Kind of conceding that Moses just made it all up. Okay, he was making the law. He wasn't hearing it from God. Okay, he was making it up.
So here's the really clever part. Michelson and Morley reasoned that if the Earth really was moving through a stationary ether, the experiment should behave in a very different way. Let's look at what happens when we simulate the effect of an ether.
This is not at all intuitively sensible, so it didn't help me any.
The light leaves the detector and gets split.
By the magic splitter, which again, no details provided.
Now here's the key. The light that travels against the ether and back again covers this journey in a different time to the light traveling across the ether.
And they imply it's a slower time. So even though it's going through thick and then it's going with the ether, which should equal the same amount of time, right? And the real trick is that this mirror is moving this way and that way. I mean, it's moving away from the beam of light. So the beam of light's never hitting the same spot on the mirror, because the mirror is actually moving sideways as the beam is hitting it. So again, all things not, the model is so incomplete, so superficial, it just doesn't do any justice.
This means that when the light waves recombine, they now interfere with each other.
By the magical, we say they interfere, magical mechanism. the magical, somehow, even though they're in different places in space, they interfere with each other. So he just pointed out how one's way behind the other, and yet they're interfering with each other. I wonder how they're doing that.
This interference means that the image will have a dark spot at its center.
So we know the spot just turns on, off, on, off, on, off. And it's sort of arbitrary, whether it's light or dark isn't really telling you too much.
See this, and you know that the void must be filled with a stationary medium through which the Earth is moving.
So all you do is you change this. You go from dark to light, and then this light band goes dark, and this dark band goes light, and this dark band goes dark. Except they go light and dark in different sizes. So again, the light bands are always bigger than the dark bands. And the dark bands are always the same size.
Now, of course, I can't be sure exactly what was going through the minds of Michelson and Morley as they began their experiment. But it's a safe bet that, given the scientific consensus at the time, they were convinced that the ether really existed. So they'd have been sure that they would have found light traveling.
So again, this is, so, to me, this is just a fight between an idiot and a moron, right? I mean, a fight over ether. It's just a waste of time. It's a stupid starting point. Why would you start with this notion that the universe is made out of some sort of goo? Why bother with that when the nothing is so obviously, it has everything about the nothing says I'm nothing. So I don't know why they have to make it into something that's pretending to be nothing. Why can't it just be really nothing? It's so simple. Anyway, probably enough of this. So anyway, I mean, this was so superficial you almost can't find fault with it because it almost said nothing at all. It didn't analyze a single bit of the physics of the process. And if you analyze the physics, it gets insane to understand how you can measure tiny differences in lengths of light beams when you can't rely on how long the light beam is. The amount of noise the system creates is so large. How could you overcome the amount of noise? Understand the wavelength of light, okay? An atom is relatively, well, I mean, it's 1,000 times smaller than the wavelength of light. And you're saying and then it's the whole idea too. They have this notion that a photon reflects off a single electron, when again the argument is no, it doesn't. The photon has to reflect off a bunch of different electrons. The pieces of the photon hit different electrons in different places to cause whatever the effect you're going to get back, and that distance is going to be a large distance. It's going to be maybe hundreds of atoms, maybe 10 atoms, but you keep adding up the number of atoms, and then you're going to build a whole wavelength worth of noise. It doesn't take much noise to screw up 500 nanometers of distance. All right. So anyway, till the next time and such and so forth and whatnot.